Yes, guys, answer.
The second.
The second.
The
يا مستر.
second يا مستر.
Yeah, the second one. Yes, excellent. Okay, the second one has more momentum, of course. Why? Because of more mass and more velocity, right? Okay, now let me to explain that again. Okay, guys, now suppose that we have two different cars or this truck. The first one very light, just 5 kilograms, and the other one and move by 5 meters per second, and the other one more mass and higher speed. Of course, this one has more momentum because more mass and more speed. Okay, let me ask you another question. Suppose that we want to stop both objects. We want to stop this one and the other one. Which one it will be easier to stop? If your younger brother play by this car, maybe you can stop him by your leg, right? Or by your hand, very easy, okay? But of course, this one take a lot of effort to stop, okay? Another question, guys. How many times that we take for the first one to stop? How many times? How many seconds or how many minutes? But the other one, this one should have very strong brake and take a lot of the power to stop or a lot of force to stop, and also a lot of time. Maybe it takes maybe 30 seconds or 1 minute, okay, or more to stop, right? Why? Because of more mass and more velocity and also more momentum. As you see here, guys, we have relationship between time, force, and the momentum. If you remember, we said that the momentum symbol is P. We can say that delta B, which means change in momentum. Now we have relationship between force, time, and momentum. We have relationship between force, time, and momentum. Force, time, that is the new thing we will take today. That is called impulse. Okay, that is called impulse. Impulse, which means force times time. Okay, force multiply time. As you see here, when we have more force, we have more momentum, and more time in touching, we have more momentum. We explain that now more, but let's explain the impulse. Okay, let's talk more about impulse. Okay. As you see here, guys, we don't have a symbol for impulse, but we can say that the impulse it will equals force and time. Okay, force and time, that is impulse. And also, guys, impulse, we have relationship between both. At the beginning, guys, let's take the SI unit. Okay, we said that impulse equals F times delta T. Now F by Newton, T by second. Now the impulse measured by Newton times second, okay, or Newton second. That is impulse. That is impulse unit. Let's talk more about the relationship between impulse and force and time, and that is very important to understand because we will use it every day, and you can see it every day. Physics, guys, in our life. Physics not come for another planet. Physics in our life, you can see it every time, and we are explaining that. Okay, now where we can find the impulse to explain how can we use impulse in our life. As you see here, guys, we have direct proportional between impulse, force, and time. What does it mean? It means when we have more force, we have more impulse. When we have more time, we have more impulse. Look over for this example. Okay, this is the golf ball. We have here touching or collision. We have time when this golf hit this object. Can you see that, guys? Now we have force and time touching or time collision. When we have more force, we have more impulse. When we have more time when both touching each other, now we have more time, we have more impulse. What does it mean? It means that if you want to increase the impulse, you should to make more force, and also you should to touch the object more time. Let's take this another example to understand more. Suppose that we have this supermarket car, and you want to push this supermarket car with the huge impulse. Okay, what you will make? You will do two things. The first thing, you will use your hand, okay? That is the car, a supermarket car like that, okay? Now, first thing, you will use your hand to make big force. The second thing, you will touch this place long time before you release it, right? You will do two things here. More force, more time to give more impulse. Now, another example about that. Look over here. Sorry, just a minute. Look over here. We have touching between this boy's ball and this wooden racket or something like that. I don't know what the name, but this is a boy's ball. Okay. Now here we have touching. When we have more time with touching, when this object touch the ball, more time and more force, we have more impulse. Look over for this football player. Now he will touch the ball by his leg. When he touch the ball, more time and more force, we have more impulse. Now we are explaining the touching time. To increase the impulse, you should to touch the ball with your leg more to give the ball more impulse. Okay, now as you see here, guys, we said that impulse F delta T. More force, more impulse. More time touching or collision, we have more impulse. And we said that the impulse equals change in momentum. Change in momentum. This football player, he will change the momentum for this ball. What does it mean? It means that he will change the velocity for this ball. He will change the velocity for this ball. If you remember, we said that the momentum equals m delta v. We can say that here F delta T equals M delta V. Okay, that's right. Let's write V by another color like that. Okay, now F delta T equals M delta V. Now impulse equals change in momentum. When this football player change the momentum for this ball, in fact, he changed its speed, right? Now that is called momentum impulse theorem or impulse momentum theorem. Let's explain this part, guys. Okay, now let's explain the relationship between impulse momentum theorem. What does it mean? It means that when we have impulse F delta T equals a change in momentum, which means that M delta V, or we can write like that mvf negative mvi. It means delta V, final velocity negative or minus initial velocity, like that. Okay, now let's complete explaining about the relationship between impulse and the others. If you look over here, guys, as I told you before, now if we have more force, okay, if we have more force, we have more impulse. If we have more time, we have more impulse, and that is related with or make a relationship with a change in momentum. What about time? What about the relationship between force and time? Look over, guys, for the relationship between force and time. If we put the time here down by the cross multiplication, now we have inversely proportional between time and force. We have inversely proportional between time and force. What does it mean? It means that, guys, when we have more time, we have less force exerting object. When we have less time, we have more force exerted in the object. We have inversely proportional between force and time. What does it mean? Look over, guys, for these examples to understand. Okay, look over, guys, for this egg here. Now the first one, as you see here, now the first one will damage in this dish or in the floor or anything else. Okay, but here with this below, with this egg not damage. Why? Because of the time. Here we have very little time. Suppose that, guys, the time here is 0.002 seconds. Okay, because that less time, more force that we have here. Okay, less time, okay, very small, very short time, we have more force exerted in this egg. But in other hand, we here will make long time. Maybe this one have 0.01 second. Okay, now this one long time, and when the long time we have less force exerted in this object, because that this one not damaged. Another example. I have a lot. Another example. Look over. Okay, look over. Look over for this guy. Okay, now can you see these guys? They will make all of this place, this wall made by a sponge or something like that. Why? Because when this guy hit this place, now they will increase the time collision, and the force in this case will be very, very small. But suppose that this wall made by blocks, what will happen? Of course, short time, and in this case, maybe he will die because of the most force exerted in this guy. Here, guys, as you see here, now to studying impulse, it will be very important to understand how this one work. Do you know that, guys? Nowadays the scientists made the airbag by the same idea. Okay, look over for this example. Okay, now look over for this guy, guys. Now this guy tried to jump from this place to the ground. When he jump, he will bend his knees. Why he bend his knees? To take more time when he touch the ground, and with more time we have less force exerted in his back. But in other hand, when he jump and he will still standing up without any bending his knees, what will happen? We have a very short time exert in his leg, and in this case we have more force exert in his back, and maybe his back maybe will broken or something like that. Okay, guys, now I will give you another example. Suppose that you want to jump from your room. Now you don't like physics, and now you want to jump from your department. Okay, suppose that the ground yes. Okay, now you want to jump to the ground. Okay, maybe you've broken your hand or your neck or like that. Why? Because of the little time, very short time, and the more force exerted in your body. Okay, but in other hand, if you jump into grass or something like sponge or like that, okay, now we have long time to touching this part, and long time less force. Now nothing will happen. Okay, another example. Listen, this is the airbag, guys. That is the airbag. Can you see that here? It's amazing. Okay, now the airbag, guys, the same idea. How the airbag works? Now the airbag works when they make the time longer. Okay, now they will stretch the time when he collision with this car. Okay, now long time, less force exerted in this guy. But suppose that we do not have this airbag, and that's happened with my friend, guys. But alhamdulillah, he is still alive, alhamdulillah. Okay, he don't make this safety and in his car, and he make collision, and his face hit the window, and alhamdulillah, he is still alive, alhamdulillah, but nothing happened. But of course he has a lot of blood in his face and like that. Why? Because of the very short time to collision and very long, very strong force exerted in his face. Okay, guys. Now that is we have a lot of examples in our life. We have a lot of examples. As you see here, guys, we will use impulse and momentum in our life. Okay, now let's move for equations and look over how can we answer the problems impulse and change in momentum. Now at the beginning, let's make a revision for the formula we will use. We said that F delta T, F force delta T, the change in time, equals M delta V, that is change in momentum, M mass delta V, that is change in velocity. Okay, now let's read this one and explain it. Okay, Okay, guys, I'm sorry, guys, just a minute. Now, look over here. Let's take the givens here. And I give you the mass equals 1,400 kilogram, and also he give you the velocity equals 15 meter per second. Okay, guys, and here this is the initial velocity. Okay, because he will stop at the end at rest, to rest. It means that he will stop at the end. Vf here 0. Okay, and he will stop in just 0 point, that is delta t equals 0.30 seconds. Okay, and now he wants that f. He wants f, and also he wants the direction, because f, of course, that is a vector quantity. And he said that the velocity here to west, I think, yeah, westward. Okay, now here velocity to west. Okay. Yeah, now let's answer this problem. Very simple, guys. Now he wants that f equals m delta v divided by t. We'll move t down because of the cross multiplication. Okay, now here m equals 1,400, v equals 15. Now, of course, guys, here we have delta v. Because of the vf0, now we have just vi. We will put vi, just vi. Okay, we don't care about the other one. But of course, if we have two numbers here for v, we will make subtract. Okay, now but here we have just one v. We will put it here. Okay, now delta t 0.30 by calculator. Okay, it equals at the end 70,000 Newton. We can say it like that: 7 times 10 power 4 Newton. Okay, the same. Okay, that is the force, guys. Okay, what about the direction? The direction here, it will be the opposite of this direction. Do you know why? Because the car will move in this direction. Okay, or I'm sorry, let's make in another direction. Okay, now the car will move in this direction like that to west. Okay, and he will make collision. Okay, he will make collision in something here. Okay, now this car move in this direction, and the force come from this object in the other direction. Okay, guys, the force come from this object exerting this car in the other direction, because that here it will be to the east. Okay, guys, now that's it, explaining for the impulse and momentum. I hope you understand. I hope you enjoy. Thanks a lot. See you next time, inshallah. Assalamu alaikum.